All good? Okay, perfect. One of my colleague couldn't be here. He had a medical emergency. Gopala, who you might have seen yesterday, so he'll not be here today. So I'll be taking the whole session. We're going to do a lot of interesting things today. I hope most of you have laptops. Some of you don't. This is a workshop, so there's going to be a lot of hands-on. If you don't have laptop, if you have mobile, it's okay. Follow along. There's a lot of links. At least save those links if you do not have laptop at this point. That'll be helpful. The main topic is multi-agent, and we're going to build and see how multi-agent applications are built using the API from scratch. So it doesn't use any LangGraph, AutoGen, CrewAI, and all of that. This is more like a design pattern. So we'll see how to build those things. What are the individual components that are required for that? Now, before we start, there are two dev platforms that you need to be aware of. One of them is the Google for Developers, which is the free one, which is what we'll use today, which a lot of you will be able to use. The other one is the cloud one, which is the Vertex AI. Now, there are differences between both the platforms. The one is built, so for example, the cloud one is built for enterprise kind of application. So you have to be aware of that if you're trying to build anything where the data is paramount and you have a customer's data or your own data where you don't want to sort of send it to Gemini, then you would prefer the other cloud Vertex AI. Sorry. But if you're trying to build a POC or a prototype, you will prefer doing the developers one. It just requires a Google account, which is Gmail or something. You do not need anything else. You don't need credit. However, I'll show you how to get $5 credit if in case you want to implement anything on Cloud Vertex AI. So this is just one thing to remember. This is how both the platforms look. Again, I've given the QR codes, scan them. If you're unable to see, I'll share it outside in the booth as well. But this is the link. Most of what we'll do, you'll be able to do pretty much everything on the left side, which is the AI Studio part. How many of you have played with AI Studio, Google AI Studio? A lot of you? Okay, good. If not, you should. It's a great tool. It's free. You'll be able to play with a lot of models, the new models as well as the old. You'll be able to do multimodal live API, which Gopala covered yesterday. So you'll be able to build a lot of things with that. The one on the right so you'll be able to open this up without any credit. You'll be able to play with this. However, you would require some credits since it's an enterprise platform. It's very similar to Azure or AWS, so you know that those things require credit. These two platforms are separate from the consumer app platform. So this is a Gemini. This is not what we are discussing. This is the chatbot. This doesn't have API. So that's not the one that we are discussing, right? So just to be clear so that you know the different platforms and things that we are going to deal with. So we'll do two things. First, we'll try to get the credit so that you get the $5 credit for your cloud account. And then I'll show you how to get the API key for the developers as well. So go to this link. Some of you may get errors. If you do get errors, come outside after the session. I'll show you how to get that. But go to this link. There's a QR code, so you should be able to scan and get the credit. The next is you should be able to see a screen like this where it is asking you to sign up. Do not use corporate emails, just use your normal Gmail. So you should be able to sign in with your account. Once you do the sign in, now some of you might get error. That's fine. Just stop there, come to me on the booth. I'll share a different version and you should be able to do the access. But if you're able to do that, just click here to access your credits. This way you'll be able to apply that $5 credits to your cloud account. Cloud, any which way, if you're doing it for the first time, you get $300 credit for free. So this just adds on to that credit if you're doing it for the first time. If you've already used GCP with your Google account, then this will again be added as a $5 and not the $300 that you have used before. So then there are a series of steps that you have to go through. Once you click on next, it'll ask you the first name, last name. Just do the accept and continue. You might have to create a cloud project, which is what you can do at the top where you see no organization. You should be able to create that, or just create a select project. Once you do that, you will see something like this on the right, which is new project, and you should be able to create that. In that, because you're doing the credit, you'll see something like Google Cloud Platform Trial Billing Account. You'll see that, and you should be able to add that $5 and just do the create. This is one way to check whether you're able to get that $5 or not. You can actually go to the billing in the Cloud Console, and then you should be able to see the Google Cloud Platform Trial Billing Account, and it should show $5 if you're able to do this. Again, not to worry if you're not able to follow this right now. Just come to me on the booth and I'll help you out setting this up. The second one, which is the most easiest, and again, both the models are same, it's just the platform difference. If you're trying to do prototype, this is an easier one. Just sign in into Google AI Studio, and on the top left, you'll see a get API key. And that's pretty much it. You get the API key, and that's all we need for the workshop. Here are cookbooks which are important. Again, for both the platforms, they are different. So on the right is the cloud ones. On the left is the Google for developers one. These cookbooks are very important because this has pretty much all the examples that you may want to build. It has all the samples that you would like. So do take a photo of this so that you can refer to this link at the later stage. I'll spend quite 5 seconds there so that you can take a photo. All right. So the next thing is, and we'll do the hands-on on this, which is the unified SDK. The new unified SDK sort of helps you do two things. One, you can actually develop everything in a single SDK, irrespective of which ecosystem you choose to. So for example, you can do a simple pip install Google Gemini, and it's just the difference between the authentication. On the left, you see the Google for developers where you need the API key, which we just got. On the right, you would need a credit system or the cloud system. That's the only difference that you need. Rest, the code to get the generation out of the model will be same. So you can see the client.models or generate content. You just mention your model and it will be similar in both the cases. This is the SDK we're going to use, and I'll show you the changes that you need to do. Rest, everything sort of remains the same, except few things which are specific features in the platform. So this is the Gemini SDK that we'll be working with. There are many other SDKs, but we'll focus on the Google Gemini one. Okay, so again, these are the links of the notebooks. Take a photo, and I'll talk about what we're going to cover in this notebook. So there are two notebooks that we'll walk through. One is the Flash, Gemini 2.0 Flash base, and the other one is the thinking model, just like you have O1, O3, and R1 model. So you do have a thinking model from Gemini 2.0 as well. Now, the context here is that we'll do this hands-on to understand the basic components of agents. What is that it requires to build agents? So before even we go and build a final agent, we'll try to sort of understand specific things like, for example, how do you get defined, structured, or control generation out of a model? Which is to say, let's say if you want a Pydantic object that comes out of the model, how do you do that? How do you do grounding generation with Google search? So if you ask a question and you want it to search Google before it answers you, we'll see how that happens. We'll also see how function calling happens, code execution, and how the thinking model works. Again, the way we are going this is very step by step. So this is important because this will become the part of the agents that we'll build eventually. So this is the cookbook that I gave you the link. So this is the cookbook where you have all the examples that you would need later. This is the cloud one. And this is the first notebook that we'll do, which is the Intro to Gemini 2.0 Flash. You do have different options to actually open and run this. So the first one is you can just open this in Collab. You can also open this in Collab Enterprise if you have a cloud account and if you've gotten the $5 credit. And there are many other ways you can run it. We'll do the first one, which is the open in Collab. And I've already done that. I've already ran the notebook. And you can actually run it with me. The only thing that you would need, either you need to have an API key or you need to have the cloud account. Is this visible in the back? Or should I increase the size? This is good in the back? Okay. So like I said, the first thing is we'll do the installation. So you can see we are installing the Google Gemini SDK. Then we do the authentication. This is the authentication which authenticates with your account. So whichever account that you've opened this for, this is important for Vertex AI, not important for Google AI for developers. Then we import couple of things. So you can see the import commands that we are doing. And this is where we add the project ID. So again, if you're doing this on cloud, you would need your project ID. So you can see my project ID here. So I've added that. Once you do that, the other thing that you can do, and again, you can copy the API key if you want, it'll get deleted. This is the other one. So the same thing, I'm just creating a new client, and this client I'm actually creating as a ML client, just to show you that the whole code remains same. It's just the authentication at the top that sort of differs. So you can define this as a separate object. I have defined the model. So yesterday itself, the Flash became the GA. So now rather than calling at Gemini 2.0 Flash EXP, if you've used it, now you can actually just call it as 001 because it's GA now and it is out of experiments. The very basic way of calling the model is this. You just use the generate content method, pass the model, whichever model. So it has the Flash Pro and the older 1.5 models as well. And you can see these two examples. In one of them, I'm using the client, which is the cloud client. In the other one, I'm using the ML client, which is the API one that we created. And in both the cases, you can see the code remains the same, except the client object that I'm using, right? The first one is client, and the second one is the ML client. And both of them are giving you the same answer. So this is, again, just to enforce the idea that this is unified SDK, which means you can just change one authentication at the top. Everything sort of remains the same. And in the content, you actually pass your prompt, and then you are just displaying this as a markdown, or you can just print it however you want. You, yeah. The first one, yeah. Just take a photo of this, and then you can open. All right, good. Okay, so a couple of things. So one is, this is the streaming generation. So you can again see the method change from generate content to generate content stream. Sometimes you want the outputs to be in the streaming format rather than sort of in just one go. So this is how you do it. You just add a for loop so that it collects all the chunks and then it prints it. I have already printed this. So you can see that every time it prints, there's a line that I'm also printing just so that we know that it's sort of coming in streaming. Just again, a simple way to get the model. You also have a chat. So you can actually do multi-turn chat as well. So you just create a session. So this is where I'm creating a chat session with the specific model ID. Then I write chat.send message and I send whatever prompt I need. The good thing with chat is that it remembers the context of the first message that you send. So for example, I say write a function that checks if a year is a leap year or not. And you can see that it gave you all the things. It gave you example usage, the improvement. The next message that I send, so you see the same chat object, send message, and I am saying write a unit test of the generated function. So it remembers the context of the previous. So this helps when you're trying to do, let's say, more conversations. Again, something very important if you're trying to build an agent, because agent can be conversational agents, or it can be just one-off where you define the task and it should be able to do that. And you can see that it was able to define the test cases for the whole thing, and that pretty much sort of summarizes, and it gives you the key improvements and how to run the test as well. This is another one which is very important, and this is something which Gopala also talked about yesterday, which is how do you do async request. Anybody who knows what is the difference between async and normal generation? Want to give it a try? So WebSocket is one where you use this, but other than that, like, let's forget about the WebSocket, but why would you use async model? Sorry. Two-way communication. What else? Anybody else? Multiple requests, right? So the most important thing is, and again, think from an agent perspective, right? Agent has to do many tasks, right? So one way is, of course, to send the sequential. You keep on sending request after the request, or you can sort of just send parallel requests because they are not connected together. So for whatever reason, if you have parallel tasks, you might want to use the AIO, which is the async generation. This is something which we use heavily in the agent. When you'll see the agent code, you'll get the idea that this is something that we use heavily, because each agent does something different and they don't have to depend on the output of that. So you can actually parallelize them in this sense. Just a caveat, it is not actual parallelization. It's just a different request at the same time. So this is how you do that. Pretty much everything is same except the client.aio. Rest everything remains the same. You can also sort of define the configs. So this is where, if let's say for you wanted to sort of define the temperature, the top P and top K, and you also sort of want to define the output tokens. So in this case, you can see it as 100. And you will actually see that it actually stops in between because I've defined that. So this is another way you can actually define the parameters if you wish to. Here's another example where you can define the system instruction. So you can see that in the instructions I'm saying that, hey, do the English to Spanish translation. And then in the prompt, when I say user input, I like bagels, it sort of responds in the Spanish, right? So you can actually create the instructions at the top. That really helps you set the tone of how the model functions. The other one, this is also very, very important, and a couple of you asked yesterday as well, that how do I control the safety settings? Like I want to either have no safety settings, or I want to sort of block certain things. These are pre-configured one. So you can see that I'm taking an example where explicitly I'm sort of trying to ask a hateful and mean comment. And because I'm sort of doing block and harm of all the safety settings, you can see that it actually blocks everything and it gave none as an answer. So this is also very useful and important, because again, you may want to control the behavior of agent. You may want that, certain things should not pass through. The next thing is very important. Again, something that you'll see a lot in the agents, which is how do I send the multimodal inputs, right? And again, some questions were around this yesterday as well. So you can send these different kinds of data type. You can send text, which is what we have been sending so far. You can actually send the code as well, which will, again, the MIME types are important. You have to remember this, because MIME types makes the API understand and the model understands what is the data type that you're sending. So you can send a code. You can actually send a PDF directly without the need for you to convert this. One thing to remember is what Gemini does when you send a PDF is not that it extracts out the text and sort of uses it. It actually considers each page as an image, because it has that capability of OCR and all. So if you have, let's say, some use case where you want the images to be part of your extraction or some reasoning, you may want to use the application PDF MIME type, because it can access the whole document. And again, with the 2 million context, you can actually send hundreds of pages of images. If you want to send image as is, you can again use the MIME type of image/JPEG. You can also send audio. Audio has different formats, as you know, so you can define the formats, and these formats have to be correct. So whatever audio you're uploading, you should know that these are the different MIME types that you have. Same with video. Video has different things. One thing to remember is that in all the cases, you can either send a local file. So if the local file is sitting at your system, you can send that. You can also send a generated URL. So let's say internet URL or something, or you can actually store them in the cloud storage. So let's say if you have something which is enterprise data or customers data, you may not want to do the first two, right? You may want to put everything in a bucket and then sort of give the access. So it's very easy to do that, because then you can just define the URI and it'll pick up those things. So this is one example where we are actually downloading a simple image from a cloud storage. So you can see that I'm getting this from GS. This is not internet link or something. This is a URI for a GCS thing. I'm loading this. I'm again calling the model.generate. The way you pass this is this. So you call a part.from bytes. You pass that bytes object. In this case, I'm passing the image. I'm defining the MIME type, which is image/PNG. And I'm simply saying write a short and engaging blog post based on this picture. And you can see that I'm actually using the media resolution as well. You can define the resolution also of the images, whether the Gemini should see the full resolution, half resolution, or the media resolution. So you do have those as well. Now, when you do that, you can see that it pretty much gives you an engaging blog, understanding what the image is, and then it creates the blog of what you have actually supplied. Similarly, this is how you send the PDF. This all, again, it might sort of look very basic, but eventually when we try to build up the end result of the multi-agent, you'll see all of these things will come together. So the next is the PDF. We are passing the attention is all you need paper. So you can see that the file URI here is a GS link, which is a GCS bucket. And we are passing the PDF, and you can see the MIME type is application/PDF. And all I'm saying as a prompt is summarize the document. Again, you can see that it goes through the document, summarizes the document, and because you're asking it to summarize, it sort of summarizes the whole 20, 30 page document. Same thing with MP3. I'm passing internet link, which is an MP3. I'm passing the MIME type as audio MPG, and I'm saying write a summary of this podcast episode. Again, it goes into detail, figures out what this has, and it sort of gives you the whole thing. This is the new one that we only have a support in 2.0, which is you can actually pass a YouTube URL. So you can actually just say this is a YouTube URL. You define the MIME type as video/MP3. And you can ask very interesting questions. You can say, at what point in this video is Harry Potter shown? And this is a Google 25 years in search video. It's a very fast moving video. There are so many frames. There are so many different frames that happens. And when you ask, it actually tells you that video contains Harry Potter related content from 56 to 1 minute. This is very interesting. Like, you should, sorry? Yeah, go ahead. For the, okay. So if you go to AI Studio, oh, sorry, I'm offline. Don't use my key, it will not work.
Yeah. I'm trying to put my API key, but somehow it's not taking.
You're getting error. Where are you putting the API?
After the project ID,
Oh, don't use this. Don't use the Vertex Express mode. This is a separate API. So for you to put the API, you can just use this.
okay. That block the code is not there in that mode.
Oh yeah, it's not there. I added. Correct. You're right.
So I'll add
It's just that you have to add API key equals to whatever your API key is.
Yeah, just a minute. I'll take a photo then.
Don't take my key. Yeah, you just have to put API key equals to whatever your API key is. Okay, multimodal live API, we did the session yesterday, so I'll stop here. Now, these are some of the very important elements of it. Please pay attention. This is what the very fabric of agents will be in terms of agent communication, agent, how they perform things and all. So the first one is the control generation. Sometimes when we want the models to output in a very specific data structures, we want the models to follow specific things, right? So in this case, you can see I'm defining a class. This is a Pydantic based model. I'm defining and I'm saying whatever I ask. So if you see the prompt, list a few popular cookie recipe and their ingredients. I'm forcing the output in a specific data structure, which is name, description, ingredients, and I give all details of what each of this data type will be. Again, like I said, this is important because when you have to create multiple agents and each agent has to talk to each other, they can't talk in text. They do talk in the Pydantic objects or any object or data structure that you define. So it's very simple. All you have to do is you add in the generation a response schema, and then you pass the Pydantic base object in that. So now when you see the response.text, you can see that it actually follows that, right? See description, classic chocolate chip cookies, ingredients, and the name. You can be more nested. You can actually give more details of it. And to do that, you can actually define a much more comprehensive open API schema, which is like this. So you can define this as an array. You can say that each item has to be an array, each rating has to be an integer, flavor has to be a string. So you can do very complex schema design. Yes. On the model side. Yeah. Models are trained to do that. So again, the second prompt that we give here is analyze the following product reviews, output the sentiment classification, and give an explanation. So again, we gave 2 reviews. And you can see again what we are doing is, first is we define the MIME type, which is application JSON. So we are forcing the model to only output JSON. And the second is we pass the response schema. So now you see, we get the explanations, we get the ratings, flavors, all of that in exactly the JSON format that we need. So these two examples are very important. Again, remember, you can either pass a Pydantic object or a base model as you define. The limitation here is you can't do lot of nested structures here. So if you, for whatever reason, your data structure has a nested, what you do then is you define an OpenAPI schema 3.0 schema, which looks like this. The easy way sometimes, and a lot of time even I do that, is you can actually just have a general schema that you write and just ask any ChatGPT, Gemini that, hey, can you give me an OpenAPI 3.0 schema specification? It'll give you this and just copy paste and get the answers, right? So this is the element one, which is important. The other is counting of the tokens. Again, important because you want to know how much you're processing. You can actually compute all of this along with the token IDs. This is another one which is very important. This is something that we'll use in the agent, which is how do you ground the results that you ask. So again, one of the biggest issue with LLMs is that you ask a question and it is often not grounded in, let's say, some reality, some facts or something, right? One very easy thing that we can do in Gemini 2.0 is you can define a tool. So in this case, I'm defining a tool which is embed, which is a Google search. So what this forces the model, you can see in the config, I'm actually saying, please use Google search tool, which I've defined here, when you answer the question that I asked. So when it says, I'm asking, when is the next total solar eclipse in the United States? See the answer, it tells you that next is August 23, 2044. And the good part is, it actually did the Google search to give you that answer. And you also get the URI of where it is. Again, I'm not connected. You don't need API key for this. This is embedded in the API, in the this, and the token cost is cost, not the Google search. No. Yeah. So the frames in the video gets calculated as a token. No, no, the frames, and there's a calculation given on the documentation. You can have a look into it. We'll come to the questions actually. Just after this, we'll come to the question. Then you can ask the questions. Can somebody get me the Wi-Fi for this room? Audi 2. I think I did connect this yesterday. Let's see. Yeah, so you can see that this is the link that it used to get that answer. And it's a pretty reliable link. It uses PageRank algorithms to figure out what is the most reliable link, right? Very important, again, for all the fact-related questions that you have to ask, this is going to be very important. This is, again, for somebody who has, let's say, so you can do the grounding with Google search, but what about if you want to do a grounding with your own data set, right? In the same API, there's a tool called as Vertex AI Search. This has the vector DB, everything integrated in the back. You can actually create this. I'm not going to go in detail, but you can create your own data store where all your documents are there. Then when you ask a question, it will give you, so for example, what is the company culture like? All your documents are there. It will only give you the answer based on those. So it's almost like a RAG, which is hosted RAG. You can just define the documents, get the data store ID, and do that. You can have, again, you can just Google search Vertex AI search and you'll get the idea. Okay, next important component, function calling. I'm sure function calling is something that a lot of you have already experimented. So we'll see a quick way of doing it. So let's say I have a function called as get current weather. And what I'm doing in this is I'm sort of creating a simple map where I have Boston, snowy. And again, think of this function as an API, some API which when given a city, it gives you back the weather of that. Right now, we're just doing a simple mapping, and this is the definition of the function. What you can do is, just like you did with the Google search tool, is that again, you can say, what is the weather like in Austin? It will use this tool as a function, and it will automatically do the mapping. So you don't have to write the middle layer of doing that mapping automatically. And you can see that it does figure out that you're asking for Austin, and it knows that Austin is hot. in the mapping it is given at least. And then you can see that it actually gives you the answer. It is hot in Austin TX, right? So this is again very important grounding functionality. You can also do this in a more detailed nested way, which is you can actually define the function declaration. So you can define the declaration as the name of the function as get destination, the description of it, the parameters that it accepts. And you again do the same thing, which is you define the tool, you define the destination tool, and then you say, I'd like to travel to Paris, and it says Paris is the destination, and the name is get destination. So this is your invoke call, invoke function call. So sometimes when some input comes, you want to sort of invoke and hit certain other specific API. So you get the arguments for that API pretty much with that, right? So these two, again, very important design patterns. The first one is the Google search. So when you pass the Google search tool, it does the grounding with the Google search. The second is you can define your own functions. Internal function can be anything, and it will do the grounding with that function. And the third one is it will create the arguments for the function that you need to do that, right? Okay, the last one, I think, is the code execution. So this is again very interesting. You can actually create, you can automatically do the code execution. So for example, and again, all of this will make sense when we'll go to agents. Let's say there is some kind of a calculation you want to do, and that calculation will be much better because we know reasonings are very poor when it comes to any calculation in the LLM. So let's say I want to calculate the 20th Fibonacci number, then find the nearest palindrome to it, right? If you were to ask this question to non-reasoning models, they are going to hallucinate, they're going to give you random things, whatever it finds, right? But what you can do with code execution, and again, you can see we are using the tool here, which is the code execution tool. What this does is it creates the code, runs the code in the back, and this is only applicable to Python as of now, gets the answer, and that's what it gives you in the end. So it created that function, ran that function, you can see, and then it gave you the final outcome, right? So this is very important when you have to do some kind of a calculation. Many a times we face this issue. So what you can do now is you can simply write the prompt that, hey, I want you to do this, pass the relevant data if you have for whatever reason, and then let it do that calculation by writing the own code, right? So with that, this is the first part of it. I also want to quickly show you the thinking model. So this is the reasoning model. Everything remains same. You just change the model ID. So this is the model ID that you would have to use the reasoning part of it. So you saw the code execution part, but the reasonings are also very interesting. So this is how the reasoning works. So let's say what is the next number in the sequence, 2, 4, 8, 16, and then you give a space. It sort of does the calculation. This is where the thoughts come, or let's say the internal COT comes into picture. And it sort of does that calculation for you, and it tells you it's 32. So same as this. Does the Monty Hall problem change if all the doors are made of transparent glass? Again, you can see the thoughts, and it explains you how it came to that conclusion and all of that. This is also a very important component because we'll use all of these things to build that agent later, right? So again, this notebook is also there. I'll go back to the presentation. If you have not taken a photo, both of these notebooks are there. So let's take questions before we move forward. Any questions? Yeah. You mentioned about that RAG method, right? Uh-huh.
The first place itself, the model has generated the answer from RAG. And
Right.
again, the ground truth also going for the RAGs. Is it not the same thing? Because the first
It
answer
is.
itself is coming from my own RAG options, right? And I'm grounding with my own RAG again, right?
So you're talking about this Vertex AI search, right?
Yeah, where you mentioned about it is more or less like a RAG option here, right?
Yeah. So this is when you have to ground on your data. The previous option was, the previous option was grounding from Google search. Well, let's say your document has something which is not available on Google or something, and you want to do this securely on your documents on GCP and all. That is where the Vertex AI search will be helpful.
How about the embeddings and all that for
It'll take care of it. So all the indexing and everything happens in the back. Once all of that happens, you just give the data store
as a
ID.
groundwork, I need to do all those things.
Yes,
before.
in the back you have to do. So just search for Vertex AI. It's a whole topic in itself. We can go there. But it's a hosted RAG solution. So you can do indexing, embeddings, all of that happens in the back. And you just mention the ID, and then you do your stuff the way you do normally.
Okay. Thank you.
Yes. Which code? There's a compiler in the back on the client side. So it does that. Yeah. No. Right now it's only Python, and the compiler is at the back, so it does that and give you back the results. Not this on the client side. Sorry, on the server side, not on the client side, not on the local thing. Yeah. Yeah, on the server and give you back the results.
Yeah.
Non-functional as in? Right. Right. So prompt caching is there. I didn't show that example, but it's there in the Gemini by default. So you can actually cache your whole prompt and reuse it again and again. So A, it's fast, and B, it doesn't use too much money all the time you send the prompt. So that is one. The second, I think what you're saying is the profiler, which is like, I want to know the latencies and all. So if you use this in the Vertex AI side, like the cloud side, you do get all these reports and everything in that, not on the Google AI for developers. Then you have to calculate everything on your own. So the count of token you have to do on your own, the latencies you would have to profile it and all of that. Yes.
High
Uh,
level.
for the
I'll
for,
take that.
for the tools, is there a common interface you have to implement to make your own custom tools, or is it like, how does that whole thing work? If I want to
So
make my own tools,
exactly like you see here. So if you have your own tool, you'd either define it like this, or you define it like this.
so there's no like function schema that needs to be met or anything like that. I can just put any
As
number of
long as you're in
parameters.
the open API specification, it should be
Okay.
fine.
Okay.
And I'll show you the example in multi-agent. I'm using two different APIs, so you can actually go through that code and see how I did that connection.
Hi, Lavi here.
Yes.
Yeah, here. My question is on the
Sorry. Oh yeah.
my question is on the thinking model. So in the process, it thinks and generates the response, right? And as a result, it must be consuming a lot of tokens because it
Yes.
will.
Yes.
So are these tokens which are generating during the thinking process going to be charged to the end users?
Yes. It'll be on your cost center. Yes.
Okay, and then is there a way we can limit or control this thinking process, like you mentioned, chain of thoughts, or we can adapt tree of thoughts or
No.
something? No,
Right
not.
now, no. It depends on how you write the prompt. So if you're trying to ask a very complex question, you can define constraints in the prompt itself, saying that, hey, I want you to do this, but refrain from doing this, or this kind of a path. Then you may control that. But it doesn't control, there's no parameter as of now to control that.
Okay, okay, thanks.
Hi.
Yes.
Hi. Hi.
Uh,
In the pre, can
Hello. Yeah.
Yeah.
Just, I mean, just to get the detail or the basic understanding of how this, because I have used the Google OCR,
Mhm.
so now it's an advanced version where this also uses Google OCR at the back end. So what all architectural details or the code base or I'm not I mean not asking the full and all.
Yeah.
So just for understanding purpose, do we have any documentation or repo somewhere?
For the OCR?
Not OCR, for the Gemini 2.0.
Yeah. There's a whole set of documentation. Just search online, you'll get that. I forgot to add that, but there is a documentation.
Thank you.
Yeah.
so
So that you do on their side. So if you use LangChain, they have a connection with both Google developers as well as Vertex. So you would use their SDK to do all of that, not through this. This is purely when you have to do everything in this SDK. If you want to use LangChain, Llama Index, Crew AI, whatever those, they have the connections in the SDK there for the grounding and all that as well, right? Yeah, go ahead. Sorry.
for the code execution, the code it generate will be on us, correct? So we have to pay
Sorry,
for that.
on the server side, not on the client side. I
But
said
we have
that
to pay
mistake.
for that actually.
You have to make?
The code is generate to execute. We have to
Uh-huh.
pay for those token, correct?
Correct. So all the token cost will be added in that.
So
Correct.
Is there any limit how long it execute the
The
code?
2 million token is
No,
the
not
limit.
million one.
Uh-huh.
The code execution time, how long it can run?
Depends on what you have asked. If you've asked like
is there
some
a timeout
simulation.
actually? Like, is there a restriction on that one?
There happens a timeout sometimes when you try to do any complex things, but those are essentially because its server is overload or something. But yes, if it crosses, you like if you ask it a very complex question, it does sometimes fail in that.
Okay.
Yeah.
Hi.
Okay, fine.
So I'll take one more question, then we'll go
Yeah.
forward. Any other question? Again, I'll be outside in the booth, Google Cloud booth. Happy to discuss more in detail.
Hi.
Just one
If
more
we have a 2 million records here, this one.
Sorry.
Here, the other corner.
Oh, sorry.
Yeah.
Yeah.
So if we have a 2 million records in the blob storage, so
Mhm.
we said like we have already pre-built RAG model, vector
Mhm.
database. So what is the similarity criteria it is actually using? Is there any cluster-based similarity search, or it is only searching for the whole embedding database and getting the result?
So so it's not there's no embedding that gets created when you ask a question. It's again, if you read the transformer paper, you'll understand that there's an embedding that happens internally. So it tries to find as per what you ask. So it does that as long as it's a 2 million context. But if it is beyond, then you would have to do your embedding search and all of that. So
Okay.
it's not the embedding model or something which is happening separately. It's part of the model. So the nth layer of the transformer sort of does that, figures out the closest, and then gives you the answer.
And
So it's a
what-
next word prediction rather than doing the matching, searching, and then prediction.
And is there any rate limit or rate cutter, like per
There
minute?
is a rate limits. It's there in the documentation.
So now if you say like we have a multiple clients and we want to use a single deployment ID to deploy our service across, so do you suggest procuring a single Vertex AI or this Gemini service? Or
Yes, so then you have to move to the enterprise side, the Vertex side, because there you can actually define your own quota. You can buy more quota. You can get things like 10,000 per second. Like a lot of our customers, Uber and all, they use like 10,000 per second kind of a quotas as well. Those are not applicable on the free side of things. So for that, you have to move to enterprise.
in an enterprise, do you think like procuring multiple services, like multiple Gemini services and use for a specific client, or for all the clients we can use a single
You can
service?
provision that. There is a provision throughput control also that you can maintain. So you can do all of that in that enterprise.
Thank you.
Okay, perfect. All right, so again, we'll take more questions towards the end. Let's move forward. Okay, so we saw the basic elements of how the basic API sort of functions, and all of that will be, like I said, used in the agents. But let's sort of quickly go through what are agents, how do we define that. It's a huge field in itself. There's so much which is happening. So we'll again, like I said, we'll go step by step. The notebook that we're going to do next, the QR code is here. So again, you'll see that QR multiple times. So let's go step by step. The first one, which most of us do, is we have a prompt, we send to LLM, and we get the text. That's like a simplest version, which is what we call as a simple execution model. You can also chain this. You can say output text, then again goes to LLM, and then you do that. So this is what the prompt chaining is. So this is the most simplest way most of us use LLMs. The second, which is the single agent, has two very important elements with it, right? Yeah. The QR. I'll show, there's a single slide of the QR, it's okay. Two very important elements of the agents here. One is the LLM. So you can see the LLM here. So an agent has to has an LLM connection. So there should be some sort of calling of the LLM or sending the prompt. And the second important element is the tool. So tools are important because for the actions and the observation, you would need a tool. So just like we were asking to get the weather, so that's a tool that we have used, right? So similarly, like you have Google search as a grounding, that's a tool that we are using to do actions or observations. Similarly, LLM, like I said, has thoughts and plans. So if you have to create a planning, you have to create some thought processes and all, you would use LLM. So that's like a very basic unit of agent. Whenever we, at least in the definition or in the work that we are going to see today, this is what we mean by agents, right? Again, there are many different agent definitions. At this point, this is what we are referring to when we say agents. Now, when you combine multiple of this together, which means there are multiple LLMs, multiple LLM calls, not multiple LLMs, like different LLMs. So in this case, this will be just Gemini, but different tools for agent 1 and agent 2. And there's a shared goal. So you'll have something that you're trying to achieve, and then all of these agents share that goal. They may do something individually in their own sense, but ultimately they have to achieve the final goal. And that's what these different agents, and this is what we essentially say when we say we are trying to build a multi-agent system, right? All of them, you can see that they have the same unit, which is the LLM and tool, LLM and tool, and LLM tool, right? So this is what we mean by a multi-agent system where you have these different agents. I'll again repeat just for the clarity. Any agent that we're going to build will have a component of LLM and a component of tool. That's it. And this tool is nothing but exactly what you just saw, which is the function calling interface. The LLM interface will be the Pydantic or the array or data structure control generation, right? So this is the link of the notebook that we're going to do next. Take a photo, open this up. It's a huge notebook, so we'll try to do justice in the time that we have, which is enough. All done? Okay. Okay. Couple of things before we dive into that. A lot of time people ask that, hey, why are you not using LangGraph or Crew AI and all of that? And I've said this initially as well. The goal here is for us to understand the design pattern. It doesn't mean that you cannot use this in LangGraph or you cannot use this in any other framework. Your choice, whatever you want to pick whatever you're comfortable with. The goal here is simple, that we want to understand how the agents work. What is the design pattern? How do you define the control, and how do you debug with confidence so that you know exactly what's happening before even you do go in the direction of the frameworks. The second thing is, what is the problem statement that we are trying to solve here? So the problem statement is very simple. We are taking a role of a financial analyst who in a given company, or any analyst for that matter, they do a lot of research every day, right? Through different links, either through Google, either through some API. And they come up with a report towards the end. So this whole use case is sort of trying to solve that, which is, if I have access to data, whatever that data is, can I generate a long report that can then be used by a financial analyst to send it to their peers or customers or whosoever? And a specific domain that we are picking is EV infrastructure. So let's assume you're an analyst who knows about EV infrastructure, specific to the country US, and your goal is that I want to go through specific city. I want to get all the data for that city, which helps me create a report which can give insights about whether should I invest or create anything in that city for a EV infrastructure. So that's the problem. What we're going to do very interestingly here is, in a solution format, is we'll get these queries from a user. We'll use these two API, OpenStreetMap and NREL API. This is a US API, both of them. We'll sort of analyze the whole data, and then towards the end, we'll generate the report, and second, the graph out of it. So that's the challenge and the solution that we have. These are the things that we'll focus on. We'll focus on function calling because, like I said, when you build an agent, it's not something fancy. It is those elements that we just did a hands-on on. So we'll see function calling, structure generation, async model calling, and Google search grounding. So you'll see those things being applied. It's just a simple system which is built with all of these things together. This is a system architecture of how the agent will function. So this is what we'll build as a whole. So we'll start with a user query. There's an execution agent that we'll start, which will go and do the planning. The planning agent then goes and analyze the query that the user have done so that they can extract specific entities. Again, you'll see the outputs, you'll get the idea. The data gather agent does the data gathering from the API that we defined. Then the report agent sort of takes that data, creates the whole sentences and the whole report out of it. And then there's a visualization agent which creates the graph out of it. So this is a system architecture. You can take a photo of this because you'll keep coming back to this architecture one by one. So the first one is the execution agent, which is the central orchestrator. Again, we'll see how that sort of functions. These are the core research agents. There's a planning agent, there's a query analysis, data gather, report agent, and visualization agent. And then the final one is the research output, which is the output which is as a report. And then the external API and the document tool, right? Okay. So there are two ways we'll explore this notebook. One will be the black box experience where we'll not see anything what happens internally. We'll just put a query and we'll see the final output. That is what I mean by black box experience. And then we'll go step by step into each agent and see how that sort of functions and what is being done there. All right, so let's go to our notebook. This is the link, sorry. This is the link that you'll get. Again, I'll open that quickly just in case if you want to. This is the notebook link if you have not opened it already. Now, the first one that I want to show you is how simply the agent functions. So see this query. So if you see this query, I want to understand the EV charging situation in Austin, like a simple query that analysts would ask or would want to ask, right? The output of that, because this is a black box, we don't want to see what happens internally, is that when it runs, it finally creates a report. And let me show you that report. This is how it looks. So it generates this report, and you can see I generated this in the morning, February 6, 2015. There's an executive summary, there's a citation. Citations are very important because when you're trying to do any kind of reporting, you want each and every number that is being used. So for example, 6464.this, it has to have some backing where this data is coming. And it's a huge report, like if you see, and this is where the citation is, it tells you exactly which data structure was used for it so that you can go back and cross-check whether that data is correct or not, right? So this is what we are trying to create through the agent, right? This looks interesting, right? There's such a huge report that comes out of it. So this is coming from the API, this data. So this data comes from a specific standard US APIs. So this, you can trust this data because it's from the official APIs from where this data is. That's why we have been citing everything. So when it says 60.3%, you can actually go to this and check where this data is coming from. So as it is a live data that we hit the API and get the data. Sorry? For the data, I'll show you, we'll hit that, right? You can build that layers also. As of now, we have done a simple job, which is there's an API, which is official government API where the data is sitting. We just hit that with standard definitions. Now you can control, because it's a query, right? It's a query that you make, so you can control saying, I don't want this. I want the data to be specific between this and this, so you can define that. Uh-huh. Mm-hmm. Right. So this is always live. So yeah. So right now it's not doing the website integration, it's doing the API integration, because APIs we assume are much more accurate and you can have much more comprehensive data on that. Of the website, correct. So this could be your API wherever you have data in that sense, right? But there is another version of this. So this is one. I'll come back to show you how it actually looks in the backend. But there's another version of this where you can actually see a grounded data. So again, we said we also have Google search, right? So how about when we create this report and we send each section to Google search saying, hey, can you go to the internet and find the relevant details and enhance the section with maybe more data along with the citation? That's what the second report does. So if I show you the second report, this is where you see a section enhanced with search data. This time again, it gives you those citations, and that whole section is now enhanced with much more data, which was not there previously, because previously it was only API data. Now it's API plus Google data. And if you go down, you will see that now you have links as well. So it gives you exactly from where this data is being picked. So now you have two things which are there as part of your report. So one is the API data. You can go and check where this API data is coming from. And the second is it also gives you where from the internet it is picking that data as well, right? So this is what we are trying to achieve from a report generation perspective, right? So I'll take a pause before we go and see each and individual agent. Any other question? Does this make sense, what we're trying to do? Yes?
More weightage. So does it use Google's PageRank
Page rank,
algo?
yes.
Okay. So is it entirely dependent on how Google is ranking those pages, and it's just extracting whatever
Yes.
comes first?
Yes.
Okay.
So right now we don't do a external layer of ranking. You can do that. You can add that layer saying, hey, I have these 10 links which are coming. And you can maybe on your own define a whitelist or a blacklist saying, I don't want anything from these websites. You can define those lists
Yeah.
externally to what you make a call to Google.
Okay. And if we do want to integrate another layer of page ranking algo within the agent, we can do that as
We
well.
can do that because it's just a additional layer that you'll end up building over it, right? So
Yeah.
by default, the feature is that you send a text and you ask a question, it'll give you all the citation of what it thinks it has found on the internet.
Yeah.
Now, those can be right, those can be wrong, and that layer you would have to build on your own.
Okay. Just a follow-up question to this. When the agent is creating the document, in terms of how much of it is plagiarized, is it recreating everything that it's finding on the pages, or is it just referring? Like how
Referring to
much of
the-
it is referring? And
Yes, so very, very good question. So that's why we do this step after we do this step. So the first report generation is without any Google search, right? Why? Because we trust that the API data is the ground truth, right? So with that, the agent builds the narrative or what it needs to. So for example, if you see the executive summary, it builds that based on those numbers.
yeah.
That is what we send to the Google that's saying, hey, we have the narrative, we have numbers, only based on that, create a grounding.
Okay.
It would be different. What you're saying is, if you were to do this as a first go, we say that, hey, I want Austin data, then
Yeah.
it'll go all across and it'll get all the weird data, right? But we want this to be grounded to this data point because we are assuming the API data is to be correct.
Okay. All right.
Right.
Thank you.
Any other question? Right. Token will be high, of course, because we're sending too many. So you can always optimize that. This is again a rough sort of sending. We first do this, then we send the whole to that.
In the earlier diagram, you actually added the visualization. Can it be directly integrated to any visualization tool, or
Yes. So you can actually use the code execution to do that. So for example, one thing which I didn't show you is you also get the visualization. So all the data that you saw, all the API data that we get, we actually create a code execution thing, and it gives you all of these graphs as well. Right. No, for that you have to create a separate layer. This is Matplotlib because the code execution supports the Python, right? So as of now it is limited to this, but again you would have to build that integration to do it in QuickLab or the other things. For that, you use the Vertex AI search because there you can do all of those things. So if you have your own data, your own things, then you use Vertex AI search. Then you don't use the Google search, right? Okay.
Just a question here. Do you think it's a better idea to have a
Sorry, can you raise hand?
here on the left hand side? Yeah.
Oh, sorry.
Sorry.
Yes.
Do you think it's a better idea to have a plan and an outline and have users improvise on it before we give the results?
It does that. It does that. So I have
Okay.
not. So the first one was just the input and output. I've not shown you what happens
Sure,
in the
sure, sure.
internal. So we'll go through step by step. You'll see exactly it builds the plan. It follows the plan. One thing which I was having a discussion with one of the folks as well is that there are layers of automation that you do. So this automation is that you knew the steps beforehand of a research because as a financial analyst, you know that, hey, this is my API, I go there, I search, I build a narrative and I get the report. So you know this workflow very well and you're automating that. The second is where you also do a loop around it, where you say, okay, you have this, now do some optimization, and that optimization could be analyst level optimization, it could be grammar level optimization, or whatever those. So those loops can be the second layer of automation.
Yeah, and when we are doing those iterations, some of this can be saved in memory as a long-term or a short-term memory and etc.
Right.
Right? Okay, thanks.
Right. So we are taking the first automation, but you can actually make it much more complex as you go forward, right? Okay. So
I have one more question.
Yeah.
Sorry.
can you raise hand wherever you? Oh yes.
Does it rewrite the report post the Google search? Like I get it. It first creates the report, then it searches in Google, then does it like rewrite it again?
It does. It does the rewrite of the section. That's why I have added that enhance with search,
Okay.
just to show that it has actually rewritten the whole section one more time.
So in this case, it might like create plagiarism, right? Post Google search when it
Plagiarism,
rewrites.
because that's
Yeah.
why there's a citation. So this is where the analyst would come back and say, okay, I'm picking, and that's why it's important to add citation, because if it's quoting any number, right? So 98.7, either it's from API, then you need to have the access or whatever copyright that you have, or it's picking from some website, then you need to know whether I have access of copyright or not.
Got it. Thanks.
Right? That's why citations are very important. That's why we didn't just do like just create something and then we are done. We just want to make sure there's a citation there. Yes.
So I can see that the planning agent and other agents are there. So this to and fro communication is happening between the agents, or I could see the graph as sequential only.
It is sequential. The same thing I was telling, right? Right now we are just automating one cycle of it, but you can actually do a reverse and do a loop of it. That it does that, it goes back and it enhances again and again until it reaches that. The problem is we don't have an optimization function at this point for it to do that, right? We'll come to that. So we'll go to individual agents and then we'll understand what happened. Yeah, yeah.
Or you have to give the code all the time.
The code for?
Whatever code you are executing.
The agent code you mean? Agent code we have to write, but you can generate through code execution. The tools part I have to write. You have to write. You have to write the whole schema and everything. Okay, let's go forward. We have some time. Again, I'll give you some time towards the end. We'll have a detailed discussion. Again, it's a huge notebook. You'll take another 4-5 hours just to go through it, get each and every part. So let's do one thing. Again, for you to see the actual execution system architecture, you can see how from the user query that we have, what you saw was the last end result, which is the whole report. But actually, this goes through these different steps. Again, spend some time when you have the notebook. You can see all of this, what is happening, what's coming back. So you'll be able to see exactly each agent does what does it return, then it happens what. So it gives you the sequential. And again, some of you were asking, this is currently a sequential automation, right? There is no back and forth which is happening. There's no reinvestment of the plan or reconfiguration of the plan. So it's like once the plan is done, it executes, gets you the report, right? So that would be the next step of automation where you say, no, I want the enhancement or RLHF layer of it as well. Okay, let's start with each and individual agent. So what we'll now do is we'll start with the queries. We'll go to individual agents and then we'll see what individual agents are doing so that we understand what it takes to go from a query to the final report, right? The first is the planning agent. So, and I'm calling these agents as a class object. So you can see that my query was, I want to understand the EV charging situation in Austin and a proper vetted information and some plot. So like a normal query that you do. What this does, it creates a execution plan. So this is what you see here. So the execution plan is that this is the query, the timestamp when this was executed. It extracts the city, so whatever the city is, and in the backend logic, when you'll see, in fact, I forgot to mention, but I'll show you this towards the end. The EV agent code, all the agent codes are there in a drive, which I'll share the link with you. You can actually go and look into it. Each agent is roughly 1,500 lines of code, so you'll be able to see that. I'll also show you that how you can actually learn this in a much easy fashion. But this is what it does. So it picks up the cities. So what you can see that it picked up the Austin from here. It also measures whether the query that you have given is true, in a sense that whether it's a valid query or not. The way it does is that we have defined internally that these are standard cities that we support. These are standard things that we support. So it matches with that and gives you whether it's a true or not. It also measures whether you have forgotten to mention certain things. So for whatever reason, let's say you forgot to mention Austin, it will give you the missing element and the valid will not become true, which means that the planning agent will fail there and there itself, right? Similarly, it also sort of gives you suggestion, again, based on rules that the query doesn't have this, query doesn't have this, can you enhance the query with this? Enable search, because you're asking vetted information, it automatically enables the search. This is a Google search enablement. So if you, for whatever reason, and this is again, what we are trying to do here is, we are trying to make sure that whenever user writes something, each and every part has to be extracted and become a part of the plan, right? So enable search becomes true. Then from there, it creates the plan step. So you can see this is Pydantic object, and this is why I was telling you, this is why doing the control generation using Pydantic and data structures are important, because this is all happening through Gemini, right? So it creates the plan step. The first one is please extract the entities and determine analysis parameters. And it does that. It says that the planning is pending because we have not executed it. So the execution agent has not done that. Then it goes, it says that data gather agent is this, the report agent is third step, the fourth is the chart builder. So because you have asked, again, if you notice in the query, you've asked for some plots, right? So because you've asked for some plots in the plan, that's why you will see a plan step 4. If you do not do that, the plan step 4 will not come. So this is the logic which is happening in the back, where it understands from your query what is the planning that I need to do. Nothing is executed, but this is the plan that gets created. Does that make sense? The planning agent, this is the first agent, right? I'll go back. Just 1 minute. So this is the planning agent that you see here, this one. So the execution agent implements the plan that you see there, right? Yes, somebody was saying something? So for that, you go to here, you go to EV agents, you go to agent handler, and then you see the planning agent code, and you will see all the code and the prompt and everything. It's a huge code. I'll show you an easy way to sort of put this in Gemini and ask the questions that you have. But all the agents are sort of written here. So all the agents implementations are available here. You can just download and look through it. So this is your planning agent. This is another example where whether you can see the specific validated query or not. Let's see the failed query. So you can see, I write, I want to understand the EV charging situation in Paris. Now Paris is not part of my cities. My cities are only in US. So you can see that when it does, it actually fails that. And you can see that is valid becomes false because missing element is valid city. So these are the rules that you write, whatever that rule at your end is. And that gets failed. So what will happen is it will not execute any further. And that's why you see the enable search is false and there's no step associated with this. Let's go to the second agent, which is the query analysis. So query analysis is interesting because this is where the extraction of the entities happen. So again, let's say the query is what are the gaps in Austin charging network? Report format, please. So what it does is, and this is what the output of that agent is, that A, it tells you that the pattern is gaps because you are asking what are the gaps in the Austin. So it's a simple classification. It extracted the cities, states. Research theme is electronic vehicle, which is same for all. And the output format is report. There is a report format, there's a text, there's a raw data. So you can actually ask the agent that, hey, I just want the raw data. So it will not give you the report. It will actually just give you the raw data. So this is what the query analysis agent does, which is it comes up with the extraction based on the query that you write. So this is what the query analysis does. Let's see next example. So it says need some raw data on Dallas for EV charging. Again, you see that the pattern has been classified as discovery, Dallas, Texas, electronic vehicle, and this time the output is raw data. Again, all of this is part of what you write in the query analysis agent. So again, if you see the code for it, you can see that the code, we have defined all of these elements. And it compares, it measures, this is how these different prompts does the classification, right? This is the third example. Compare Dallas and Austin. So there is also a comparison pattern type where it doesn't just do one single city, it actually compares both the cities. So in this case, you can see that this time it is actually cities, Dallas, Austin. Now again, somebody tell me that when you extract cities and states in an array versus when we were doing a single extraction, what might we have used in the back to do that? So given a query, let's say it's a simple problem. Given a query, I just want to extract cities using LLM. Right? Correct? Because what you'll do is you'll do again the same Pydantic thing that I showed you. You'll define the enum, you'll define the array saying, hey, I want you to take this query and extract the cities from it, and you give the list of cities which are permissible and the ones which are not, and then you say, I want the output in an array. So that's how you get the outputs in a proper structured format. The reason I'm sort of stressing on this is that every agent that you build, now this is where I don't want people to use frameworks at the starting point, because all of this gets abstracted for you. So you don't understand that all of this is happening in the back. So it's important that you understand that these things that you see, you have to write it in the back, and you understand that these become important from a communication point of view. Because this is what we take, and the next step then becomes important, because now I know I have to hit the API, get the data for Dallas, and get the data for Austin. So unless I had this in a structured format, I'll not be able to do that, right? So that's the thing. That's why I'm trying to show you that the query analysis agent does this very well, which it extracts the pattern type, cities, and state, right? Okay, any question before we go to data agent? Yes.
Yeah, so the query includes both the cities comparison, and there's some other prompt at the end. Like if you go back, compare Dallas and Austin for EV charging, give me a detailed report because I'm going to San Francisco, right? So what happens in that state where there's 3 cities, but your required input is only the initial 2?
Correct. That's a very good question. That's an exception. It'll fail on this, because I have not considered that. You're absolutely right. So if you were to do that, then you have to again write your prompts and the output in a specific way, that the cities that I need to extract should be in the context of what the user is asking from a report perspective. The name of the city should not be in the context of where they are going or where they're coming from, whatever that, the set is.
But then that makes it limited. Like for example, when as a engineer we are building, right, we do not know what exactly is the user going to type after they have asked for the report, right? It can be that I'm going to visit my family. Any kind of prompt can press, be a suffix after that. So how do we how do we exclude those by defining, because we won't know the full scope of what they might write?
So you do that failing in the before step, when the plan step is happening. So you again come up with a classification where it says that what are the valid queries and invalid queries. So you would have to build a set that you then give it as a few shot to the LLM saying, hey, the only queries which are allowed are these, all the combination of these, but not these. Now, of course, it's not 100%. Some queries may go out of that and something will fail, and then you build iteratively over that. And that's why the thing is, this is not a very software-driven design of it, right? This is a very LLM-driven design, which means you'll not always be deterministic. There'll be 5%, 10% where these things will fail. So you build that iteratively as you get the more and more responses.
Got it. And one question on the last place, when you use public search engines like Google or DuckDuckGo, anything like that, you have tools already built. If you know, like Google has a very good rate limiting when a single IP request hits a lot of times.
Right.
So as a company, if I am deploying my production application on a set, right, it will always come from that exact IP. And we are using the tool. How do we make it such that all the requests still go and it does not get rate limited on that?
So that's why you would then go to the enterprise side, which is the Vertex cloud side, because there you have a provision throughput compliance, which means as a customer, if you say, hey, I need this much quota, then I need this much uptime, you get into a contractual
But you said search does not come under quota.
Search will also be part of that, because search doesn't require a API explicitly from your end. That's an internal inbuilt thing. So when you take a provision throughput, it gives you for all the things. So you can do million search on that and all of that, but you have to take all of those things, and there's a cost associated. Okay, So let's do the next thing. So the next agent is the data gather agent. This is very important because so far what we have done is we have the query, we get the plan. What we also got is the extraction of what is those cities and what are those things. But the next is you actually hit the API. So this is where the heart of the whole report is, because this is where what you would want to do is you take those cities that has been extracted in the previous cases, you hit the data gather agent, which takes the API, and there's, again, you can actually see the whole code if you go back to EV agent, and if you go to API handler, you will see these two py file. One is the neighborhood summary, which uses open map. If you open this up, you will see how we have written each and every API level details as to what data do we need from the API. And then it hits a query. So this is the query that we hit in the open map thing. So you can see all these detail gets extracted from the API, and that's exactly what we are doing. So once we extract the data of the cities, the data gather agent, what it does is it goes and it takes roughly 1 minute, and you can actually define a couple of things. You can define the radius. So if let's say you're saying Austin, Texas, you can define the miles it has to cover. Why? Because in that city, it will give you amazing sort of details of it. Let me show you one example. So again, we start with a query, need some raw data on Dallas for EV charging station. So again, the query analysis and all those agents have been running in the back. It extracts the Dallas, and then it does the data gathering process, and you can see this is the data it gives. So all of you were asking that what is the data that you get, right? So this whole data, we have encapsulated that in a Pydantic object, because that's how we want to use and refer it in the citation. And that's the data you get. So see, city, Dallas, state taxes, OSM ID is so that you can go back and check and then see the details that you get. So in that 100-mile radius, you get healthcare facilities. So how many hospitals, clinics, pharmacies, veterinary. You get education details, kindergartens, how many of those are, transport, road network, retail. Now again, think about it. This is what the analyst does, right? If you have to figure out whether, if I have to create a new, let's say, charging station, I need to know what is happening in that area, right? Should I put the charging station in the shopping area? Should I put the charging station? So this is where the reasoning comes from. So to do that, we need these kinds of data. So if you actually go back to the reports now and pick a section called as supply analysis, you will see that this is how it gets translated. Those raw numbers gets translated into a narrative. Boast a total of 78 EV charging station distributed across city, mixed charging capabilities with level 2, level 1. And you can see that this sort of goes into those details. And the best part is, now when you actually come down to that specific section, it actually tells you exactly that data point it is using. So it says EV data.metadata total stations, which is 78, which is nothing but the same thing here. So now you have that citation, so it's important that you can always refer back. So this is one. So there are two API that we hit. So one was the OpenStreetMap, which gives you the locality level details. The second one is the EV infra one. So this is very important. This is where you get the total station. So you will see that the total stations are 55, area square meter is this. It tells you the total stations per square mile is 0.07, how many are DC fast, how many are level 1. And this is the kind of details you would trust, right? Because this is coming from a government API. So you would trust that data more than anything. And based on these data points is what you see here. So this is what it cites. So when it creates the narrative, it creates the demand from these numbers, right? So this is how you get that data. And again, like I said, because it is built that way, you can actually do multi-city as well. So when you run the same data gather agent, it actually returns 2 because it's doing the both, I think in this case, Dallas and Austin. So you get the data for both. So this is what your data looks like. This is how the raw data looks like. And then what you do with this data is you go to the agent or the report agent, which then takes this data. And let me show you how the prompt for this looks like. So you can see that this is how the prompt looks like. Generate a specific section. So you have defined the section for EV infrastructure, and then you pass the whole Pydantic data object that you got from the API, and then you define the citation that it needs to do, the key finding, the subsections, requirement, and then you define the requirement. So it says minimum 5 data points with citations, you define the guidelines. So this is what is happening at the report level. So the raw data that you got, you put in the Gemini, and then you say that, hey, and you, again, you do this not randomly, but you define the schema of this as well. So when we hit this, you can see that we actually define the schema of the citation as well. And that's the prompt that is doing the magic. So you again run through this, and this is how it looks like. Let me show you how actually this looks like before it gets transferred into a PDF format. Again, a Pydantic object, you can see this is how the section comes. So this is an infrastructure overview session, and it goes through all these things, and each citation is given. So you can see that number 1 citation is this, it's coming from this raw data, the raw value is this, and the context is this. So it sort of maintains that, all these things, and this is all happening because we are maintaining the COM structure in between through the Pydantic. You can see that it goes into detail, and this is just one section, which is the infrastructure overview. The report agent then does all of this async. So all sections are generated async, and then it combines together. Now this is where you will see enhanced content. This is where it is also sending that section once written to Google search, and then Google search sort of adds more context here so that you get things like this. So URL is Dallas area rapid transit. So this is again a data which is enhanced by this, and you get the value of this as well. So this is how the Google search is sort of enhancing this. And then finally, when you combine all of this, when you actually run individual, this is how the individual debug messages are happening. And it tells you that currently I'm doing this for Austin, then I'm doing this for Dallas, and these are individual sections which are generated. And then finally, it generates the report. So this, what you see here is exactly what then gets converted into a PDF. And that's the final data that you see. So this is the second last thing. And the last thing, which is the visualization agent. So the data, because now we have the raw data, you can actually use the same raw data to generate these graphs. So you can see that you can, and what I've not done is, and something you can give it a try, is you can actually put these graphs in the same document itself, so that it looks like a good report. So with this, you can see that it sort of goes and builds all of this. Okay, so coming back, and I think we have 10 minutes, what I want to quickly sort of talk about is that there's an easy way for you to sort of go through this code. What I've done is, and again in the presentation you can actually just do this, which is you can actually go to Google AI Studio, take the whole notebook. Google AI Studio can take PY file, IPVIN by both. So just to show an example, and this is again for your learning, right? Because when you go back, you have the notebook. What I did was I just copied the whole thing. You can see the number of tokens it's taking. It's 800,000 tokens. That's the beauty of Gemini, because it can do 2 million things. So then I just simply say, help me explain the notebook step by step. It goes, it takes some time. It goes and explains each and every part of the code. Then I become very specific. I say, hey, for the deconstruction of the process step by step and planning agent, because I'm focusing on, let's say, if you want to learn more about planning agent, you can actually simply say, can you go into detail of it? And then it goes into detail and gives you exactly what's written in the notebook. So this doesn't use the actual code. What you can also do is you can actually pass all the PY files. So here you can see I'm actually passing all the PY files, all the agent. And I'm specifically asking, hey, explain me what is happening with agent1.py. And then it goes into details and gives you those details. So again, this is something, because again, the notebook is used. There's a lot that's going on. If you want to sort of learn more, you can just do this very simple thing, just upload all the code. This you can just upload the notebook I've given you, right? You can just download that notebook, go to AI Studio and just put these things. The notebook link was there, right? This one. This one. Yeah, so the drive link, the other two things that I've done is you can actually use Notebook LM to get the whole review of the report that you have generated. And you can also send your code and ask the Notebook LM to give you the review. So the drive QR is this. You can take a QR. Yeah. $115. So the drive has all the report that got generated, the actual code, the notebook code, and the PDF of the code. So all of this is there. I've also added the notebook LM overview. So if you want to just listen to the whole report as well as the code, you can actually do that. I've attached all of this in the drive. There's also a quiz at 1:15 in the Google booth. So before you go for lunch, make sure that you do that quiz. There are a lot of goodies to get through that. Yeah, that's it. I'll take questions. We have 5 minutes. Yeah, yeah. Uh-huh. Good question. So I actually import all of these libraries at the up top. Um, so if you go, so this is where I do all the installation. These are the only 3 libraries that you need, nothing other than that. And then I also do the import up top, which is, okay. Just show me the error, I'll help you fix.
Okay, but
Oh, you got the error? I chose the normal one. I just ran it in the morning. Not the normal, not TPU. Normal.
How do you deploy this in a production environment? Like you can create a IPME file and deploy in Cloud Run?
No, no. So for that you have, that's why the PY files are separate. So you would have to write a separate cloud function or the, let's say, Cloud Run environment to do that. It's in the paper. So if you see the Gemini 2.0 paper, the benchmarks are there. Or you can just do LMSys. They have, I think, all the languages. At least the top one, I think, Spanish, Japanese, and all. Good question. I don't know, actually. Mhm. Yeah, possibly, possibly. Yeah, I think 2.0 you should check out. If it is not in the paper for the Hindi or any other Indian languages, then you should check Gemma, because Gemma has customized and they have trained for a lot of Indic languages. They have a specific benchmark for that. I think, yeah, it should. But it depends what is that you're trying to do. More things are not depend. Yeah, yeah. So if it is sort of very language dependent, so this one has nothing to do with anything other than English, right? But let's say the same thing, if you were to ask me that, hey, what if I want this in Hindi or let's say in Marathi or some other language, then sure, like then you'll see a lot of issues happening. That is when you'll change your strategy. And that's why I was very neutral to models and all. The focus is whichever model you use, the basic components are same across all. You'll have function calling in everyone, you have control generation in everyone. So choose whichever works for your case and then put the same structure in that. Just give me a minute. I have to, yeah. The conclude is done. I'll just take the questions outside. That's fine. The other person is coming. It's your session?
no, he's
Okay.
waiting to talk.
I'll just go there. We'll take the questions there.
All right. Yeah, thank you so much, Ravi, for this wonderful session.